folks, let's talk about Friday. So, your test will be 66 points total on Friday, over 15 questions. Now, to be fair, that's kind of a lot. However, it was 75 points at around 8 a.m. this morning, right before advisory, and I trimmed it up a little bit. So, now, when I say 15 questions, so one question is a big chart full of all the atomic structure stuff. You guys know the drill on that. So it's going to be worth a lot of points. Whereas other questions might just be like a 1-point question, just a quick, hey, true or false, or match these two things, like very simple kind of questions. There is one, what I would call a quote-unquote thinker question. I would call it a thinker question because it's a question you've never been asked before. However, all the information you need to answer that question is stuff that you've been asked before. That kind of makes sense. So it's sort of mirroring a couple of ideas that you have been doing this whole unit. You just have never done them at the same time. That kind of makes sense. So watch out for that one. It's about 3 or 4 points. Now, tomorrow, Cohort A people who are physically sitting in front of me will be doing the Flame Test Lab Part 2. And remember, your only guide is you from a few weeks ago on the notes that you took. Like, this flame looked like this, blah, blah, blah. You'll be given a couple of samples, etc. Tomorrow, Cohort B people, you do not need to come see me. That's a work day for you. You just want to make sure you are ready for your test on Friday. It will be open from 7:30 a.m. to 1:30 p.m., which is the same as always. So that's the time frame in which you need to take your test. Now, to get yourself ready for that test, we have a few things. You can take a look at your concept map. Let me give you some of the highlights here. So, of course, history is a huge part of this concept map. So some folks are more important than others. So Democritus came up with the idea of atoms. He didn't have any models. He didn't do any experiments, anything like that. So he just has a small little blurb. Whereas other folks, like, your Daltons, your Thomsons, your Rutherfords, they have a lot more information about them because they were more important. They made larger contributions. They had specific things that you can say about them. So you want to know your history. You want to know their order, okay? Now, you do not need to tell me, hey, Dalton lived from blah, blah, blah to blah, blah, blah. I don't care about that. But I do want you to know that Dalton came before Thomson. That kind of makes sense. And I want you to be able to draw and recognize the models that everybody came up with, okay? So you need to know Dalton was the billiard ball / marble, okay? And you need to know that today we have like the orbitals and all the craziness with the tiny nucleus at the center. So you want to be able to know that progression of models. In terms of atomic structure, if you're looking at any square on the periodic table, you should be able to tell me what every piece of information in that square means, okay? On your test on Friday, the one thing you're allowed to use besides blank paper is your periodic table, okay? So you need to be able, you can use your periodic table. You're not allowed to use anything else, okay? But you can use your periodic table if you want to. Because it's not like I'm going to ask you, hey, how many protons does iodine have? And I expect you to memorize that. I absolutely do not. But you need to be able to do all atomic structure stuff in your sleep. If I ever ask you a question about how many protons, neutrons, or electrons, or the charge, or the mass, or the atomic number, you need to be able to do that backwards, forwards, diagonally, up, down, all around. Like, you need to be able to know that stuff inside and out. Okay? Let's talk about how to produce light here. Let's see, who do I want to pick on? Grace. Talk to me about how light, before I even flip the switch on, starting at that point, how is light produced? Okay, electrons start in the ground state. Ground state, is that far or close to the nucleus? Flows high or low energy? Low energy, okay. Then what happens?
And then it'll move up.
Ooh, that's true, but what causes it to move up? What causes those electrons to move up? Who can tell me what causes electrons to move up? What causes them to move up? Yeah? Energy, there we go. That's a key idea. You have to add energy. So that could be sticking something into a flame. That could be flipping on the switch. Okay? Remember, light switches are kind of like They're sort of like dams of energy. The moment you flip the switch, you're sort of unleashing the energy onto whatever device is connected to it. So remember, electrons won't move up and then gain energy. They move up because they did gain energy. Make sense? Okay, so when you say move up, what's another word for that? We say move up, another term. Instead of ground state, that would be excited state. Excited, closer, far from the nucleus? Far from the nucleus, higher, low in energy? Love it. Okay. So what happens after the electrons are excited there? They'll fall back down. That's right. Light is released. And what's really happening is they're excited, they're in a higher ring of some sort. They will lose that energy in the form of a photon of light. Okay, so whatever energy, maybe the energy was a flame at first, but now it's coming off as light. And as they lose energy, they'll fall back down. Okay? Again, they don't fall back down and then lose the energy. They are losing energy, which causes them to fall back down. Pretty good. Let's see here, Nathan. If a little tiny amount of energy is given off, what color light would that probably be?
Dark red.
Dark red. Very good. What if a bunch of energy is given off when the electron falls down? What light would that probably be? Yeah, purple or violet. Pretty good. Pretty good. And what are the little packets of light? What are those even called again? Little packets of light. Photons! There we go, baby. So a high energy photon is red, a low energy photon is violet. Love it, love it, love it. Okay. And we also want to know our quantum mechanics, okay? So our de Broglie, Heisenberg, orbitals, S, P, and D, recognize their shapes. Know what an orbital is. Let's see here, Jack. What is an orbital anyways?
No, it's not, because that's the lines. The orbitals are.
It's a home for an electron.
Yeah.
We're getting there, okay. Who's on to help him out?
I feel like I'm cheating because I'm looking at the
I'm cheating. Well, tell me in your own words, what is an orbital?
It's like a space.
It's a region of space, okay.
With a high probability of finding something.
Where you have a high probability of finding an
Electron.
electron. That's right. Yep. So remember, my orbital, quote-unquote orbital, is my room during the day, okay? So this is a general area. I could be, over there by the windows. I could be in that corner over there. I could be up front. But there's a high probability that I'm in this area, periods 1 through 10 during the day. Probably about a 90% chance I'm somewhere in here, okay? So this room is my orbital. An S orbital, for example, okay, if an electron's in there, it's in that orbital. There's a 90% chance it's in that little sphere of space at any given point in time. Okay? Pretty good. Whereas an orbit is where you got like a nice little pretty circle, and the electron just sort of moves around that circle in a predictable path. Okay? That's how Bohr thought things worked. We know that's not actually how electrons move today. It was a nice idea, but we know that they're actually sort of in these general spaces, not just on a perfect little ring. All right, not bad. So you can take a look at your concept map today. You also have a review sheet. Answer key is in the Wednesday folder. Please do yourself a favor and do not just read through the review sheet answer key. That does not really help you very much, studies show. What does help you is if you work on a few problems, do them in your own words, struggle through them, and then kind of double check things, self-assess yourself using the answer key. Was there a hand over here?
Yeah.
What's up?
I was going to ask, so like the Unit 4 test is like Friday, and then you said something about like this test that combines like all the units. When is that?
Correct, yeah. So your Unit 4 test is this Friday. Your semester exam will be next Thursday, and that's the combination of 1 through 4. Your semester exam this year, compared to last year, it's much easier. However, it's still going to be kind of difficult. You will be getting a semester exam review packet before that happens. Cohort A people, you'll be given one physically before you leave this week. Cohort B people, you'll be given a review packet for the semester physically in class on Monday. So that's kind of what's coming up next week. You'll just be reviewing for the exam. And before I forget, I want everyone and their mother to go to the Wednesday folder on Schoology and get those participation points right now before you forget. Get those participation points, people. And at this time, are there any questions that anyone has while everyone's getting their participation points? Any questions at all? Yeah, go ahead.
So we're taking like the flame lab test tomorrow, right?
Correct, yeah.
Will it also be on the quiz?
Oh, that's a great question. No, there will not be any flame test lab stuff on your test on Friday. So you do not need to know, oh, lithium's red, copper's green, that kind of thing. You do not need to know that for the Unit 4 test this Friday. However, the concept behind the flame test lab, where does light come from, that we were just explaining in class, you do need to know that. Yep. Flame test lab part 2 is sort of, do you know the colors? Yep, Burrs.
We didn't have a Tuesday question quiz, did we?
Correct. There was not a Tuesday lecture quiz. Yep, good to double check. This is one of those unusual weeks. So, in terms of what you're working on, you can kind of go through the concept map. You can work on your review sheet, which most of you probably will. You also have atomic structure worksheet number 3 that some people started yesterday that you can work on. The answer key to that is in the Tuesday folder. Remember, there will be atomic structure stuff on your test on Friday. Most of you feel pretty good about that, but you want to make sure you're warmed up and you're not rusty when you get to that on Friday, okay? Well, virtual folks or remote kids, if you have any questions, please ask them now. If you've gotten your participation points and you do not have questions, you guys can go ahead and get out of here.